proportional relationships, we're going to be identifying a proportion as a set of equivalent ratios. And if you're like, a set of equivalent ratios, what is that exactly? Well, here is where we're going to get into what is proportional. And it's going to be if ratios or rates. So that's where I'm going to pause and go back here to say we're identifying if a proportion is a set of equivalent ratios. So what's a ratio again? Well, it was basically a comparison. It compared just numbers, essentially. And then a rate is going to be comparing quantities. Now, the example that I use in class was that when you go get a job, let's say you go work at Lowe's, so you're working at Lowe's, they pay you an hourly rate because it's going to be money per hour, right? You would not have said they paid you an hourly ratio because that's comparing numbers. Now, if you were to compare hourly rates with someone, that might be you're comparing ratios, but anyway, you're still comparing rates. So proportional, it is proportional if the ratios or rates of two quantities are, you ready for this? If they're equal, okay? Then the quantities are proportional. Now, immediately I'm going to jump down to this example of somebody making some cupcakes, mini cupcakes. If you're going to make 3 dozen cupcakes, how many cups of sugar do you need? Well, you could probably figure this math out just by looking at it. That's times 3. So the rate here is times 3. And then if you go down and you say how many cups of sugar for 6 dozen mini cupcakes, again, you could probably figure out this math. That's also times 3. And if you are kind of looking ahead, you're going to notice that all 4 of these are times 3. 3 times 3 is 9, 6 times 3 is 18, 9 times 3 is 27, 12 times 3 is 36. So this is, in fact, proportional. Okay? And it's proportional because each time the rate is the same. All right? And if you're like, wait, what? If the rates of two quantities are equal, then the quantities are proportional. Boom, there's your example. And then now hopefully you see where this is going. The opposite, if they are not equal, by the way, I like to write not equal like this, an equal sign with a slash through it. This means not equal. But anyway, there's the word not and the sign for equals. Then they are non-proportional. Okay? So, again, let's jump immediately into this one. So, as you look at the first one, 3 dozen cookies this time. To get 3 dozen cookies, you need 12 cups of sugar. Well, that rate right there is times 4. Makes sense? So, essentially, now we're going down here, 6. To get 6 dozen cookies, we need 22 cups of sugar. Hang on, that is not times 4. In fact, how could we figure out what that rate is? Well, if you can't do this part in your head, then here's what you have to do. 22 divided by 6. So let's do that. 6 on the outside, 22 right there. This is 3, 18, right? So we subtract to get 4. Decimal. That means there's a 0. Bring that down. 6, 36, and another 4. That means we are going to get 3.6 repeating. So what just happened is to get 6 dozen cookies, you need to multiply that by 3.6. If you don't like this as a decimal, that is 3 2/3, just so you know. So that means this is non-proportional because our rate does not stay the same. Okay? Non-proportional. And if you're wondering, well, why would we care about some of these things? Essentially, this is just kind of a little bit of a different line of thinking when it comes to numbers, is that you can look at patterns and you can go, hey, I recognize something about this. In fact, soon we will be talking about lines and graphing and things like that, because there will be some proportional relationships, right? And if you're like, I don't get it. Well, think about it like this. Imagine that we were going to graph how many cookies it took. So here's cookies. Oh, sorry, this is cupcakes. So hang on. Since this one is proportional, we'll go with cupcakes. And then on this side, we'll go with cups of sugar. So to get 3 cupcakes, 1, 2, 3, you need 9 cups of sugar. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to get 6 cupcakes, 4, 5, 6, you need 18. So 10, 11, 12, 13, 14, 15, 16, 17, 18. Like that. And then to get 9, you need, 6, 7, 8, 9. And now we need 19, 20, 21, 22, 23, 24, 25, 26, 27. You start to see that, wait a second, these are like in a straight line. So it would seem that this relationship will follow. So like, for example, if we wanted to make 1 dozen mini cupcakes, how many cups of sugar would that be? Well, it would be times 3. So it would be 3. So check this out. According to our graph, move over 1, go up 1, 2, 3. It appears to be on that line, right? So anyway, that's the concept. If you're someone who really, 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 really wants to fill in blanks, this one is about our cookie example. The sugar used in the cookies is non-proportional. I'm going to write non-pro because the rate of the sugar per dozen cookies is not equal. And now, honestly, for this one, it's for the other one, right? And so our answer is that yes, it is proportional, and it's for the opposite reason of this. The rate of sugar per dozen cupcakes is equal. So there you go. And if you're like, okay, I don't know if I get this, well, we have a little bit more to practice. Determine whether these quantities in each table represent a proportional relationship. If yes, give the constant rate. Alrighty? So number of items sold. If you sold 5 items and you raised $30, what's the rate here? Well, if you can't just figure out how to get from there to there, like I said, you're going to have to slide over here and do 30 divided by 5, which is like this, and you get 6, okay? So this was times 6. Well, guess what? This is also times 6, and so is this, and so is this. So yes, this is proportional, and the rate is times 6. Now we get hours of snow per total accumulation, or, total accumulation per hours of snow, whatever. Well, this one, it's kind of nice because we can figure out 1 times anything is going to be that thing. So times 3.5. Let me put a little different colored dot there, 3.5. So basically, if this is a proportional relationship, then 2 times 3.5 will equal 6. But we know that that is not true because it's 2 times 3 equals 6. So right away, we know that no, this is non-proportional. And if you're like, wait, but why? Well, it's because it doesn't have the same rate all the way down. Okay? In fact, if you were to look at this one, this is times 3. So it's because of these two it doesn't work, but it's also because of these two. And in fact, I don't really want to, but I could figure out why this one doesn't work either. Mainly because it's not the same as literally all of the other ones, right? So that's how we know if it's proportional or not. But let's try some other ones. In fact, this is where I would say, hey, why don't you try? So pause the video, you try, and here in a second, I will help you. So green marbles to red marbles. Well, I don't know 8 times what number gives me 10. I really don't know that. So here's what I'm going to do. 10 divided by 8. Okay, so let's see. 8 and then 10, and 8 goes into 10 once. You subtract, you get 2. There's going to be a decimal, so we bring down our 0. 8 times, let's see, 2 is 16. We're going to subtract, get a 4, bring down another 0. So, 8 goes into 45 times. So, here's what just happened. 8 times 1.25 equals 10. So that's how we got from here to here. From here down to here, okay? So then, if 10 times 1.25 equals 12, then we are on a proportional track. But we know that doesn't work because 10 times 1.25 is 12.5. So this is non-proportional because of that. All right, pounds of fudge. So let's see, 5 times what equals 4? I don't know. So here's what I'm going to do. Actually, I guess if I look at it as 5 times 40, hey, you know what? That's part of our thinking here. Because, hey, 5 times 8 is 40. So maybe it's going to be not quite 8. And if you're like, I don't quite understand. Okay, well, let's look back at the whole division thing to figure this out. So we got $4, forgot my dot, divided by 5. Okay, so 5's on the outside, $4 on the inside. Well, 5 can't go into 4, so I'm going to put my decimal and now ask how many times did 5 go into 40, which is 8 times. Oh, look, it's 0. So this times 0.8, 5 times 0.8 is $4. And guess what? 6 times 0.8 is $4.80. 7 times 0.8 is $5.60. 8 times 0.8 is $6.40. So yes, this is proportional, and the rate is times 0.8. Same stuff down here. Miles walked versus time. This first one is really nice because it's times 12. But 2 times 12 is 24, and we don't have 24. So we can stop there and say, nope, this is not proportional. Now right here, oh no, fractions. Again, you can approach it by thinking, okay, well, I have to do 3 divided by 1.5. You could do that, but also what if you took some other ones and thought through them, like the 4? So like 4 divided by 2. Well, wait a second. Hang on, I did both of those backwards, didn't I? I said divided by going that direction, and I'm not dividing that direction, I'm multiplying that direction. So it would have been 1.5 divided by 3. Okay, well, so if you don't see it still, let's just try and think of this one. 2 divided by 4. Maybe you see that, because that's 1/2 when you divide 2 over 4. And if you're like, no, I don't see it. 2 over 4 is 1/2, right? So check this out. 4 times 1/2 is 2. Do you know what 3 times 1/2 is? It's 1.5. Do you know what 5 times 1/2 is? It's 2.5. Do you know what 6 times 1/2 is? It's 3. So yes, this is proportional, and the rate is times 1/2, okay? And again, I did fast math here. If you need to write out the math here, and if you need to go, hey, 4 goes into 2, then go for it, okay? Because you will still get 1/2, right? Notice this is a decimal and this is a fraction. They're the same number though. They just kind of get used a little bit differently, right? All right, now down here, we are filling in, we're completing tables. So we're basically told, listen, these are proportional. Just complete the concept. It'd kind of be like up here if we were like, okay, so if you got 7 lemons, how many cups of sugar do you need? Which would be 3.5, by the way. Anyway, So what are we going to do? We take $1.75, and that's how much 1 cup costs. Well, how about when it's 3? Well, all you're going to do is 3 times 1.75. Now, here's where you can get a little bit, do some thinking on your own. You can either do 1.75 times 3 and fill out, take this answer and put it in right here. Or you notice that these are going up by 2 cups of coffee each time. So 1 cup of coffee is $1.75. 2 cups of coffee is how much? $3.50. So really you could do some math like that and just say, hey, listen, I'm going to add $3.50, right? And so what would that be? That'd be $5.25. And then if you add another $3.50 to that, you get $8.75. And if you add another $3.50 to that, I think you get $12.25, right? And if you're like, I don't believe him, so do this: 175 times 7, you get 35, 52, 12.25. So yeah, it does work that way. Again, this is to kind of go with some proportional thinking. This one in particular goes really nicely with this graphing concept. A car travels 52 miles each hour. By the way, that's 52 miles per hour, or mph. So after 1 hour, it's gone 52 miles. After 2 hours, it's 104. After 5 hours, well, let's see, you're going to have to do 5 times 52, which, let's see, I think that's 260, but let me double check my math before I get too overconfident. Yep, 260. And then I had a student ask me about this. Right here, they said, you know what, I could multiply 52 times 8. I could. But they also asked me, can I just multiply this? Can I multiply this times 4? And the answer is yes. Because this is a proportional relationship, you can. So, and if you're like, but why would you ever do that? I don't know, if you wanted to. So you get 416, and if you're like, how'd you get that? Well, 104 times 4 is 416, but so is 52 times 8. 8 times 2 is 16. Carry the 1. 8 times 5 is 40. So there you go. Again, that's just a little bit of proportional thinking. Now, we got to read this in question. Read this. Oh my gosh. We have to read this question a little carefully. Jose uses 1 2/3 bags of grass for every 400 square feet of his yard. So he uses 400 square feet here. That means he's got 1 2/3 right here. Okay. So we could sit here and go, okay, 400, times what number equals what? Or we could do this. From 400 to 800, that's times 2. So we could just double 1 2/3. So 1 2/3 is really 3 times 1 is 3. 3 plus 2 is 5. 5/3 times 2 is 10/3. Or 3 1/3, which, by the way, is just 1 2/3 plus 1 2/3, right? That's how multiplying works, is it's repeated addition. So check this out. Here was 1 bag, 2 bags, 3 bags, 4 bags. So if I add another 1 2/3 to this one, I get 5. Because if you add 1, that'd be 4. And then if you complete 2/3 and 1/3, that's another whole 1. And then over here is going to be, let's see, 6 2/3. So this one is a little bit of a curveball, but it required us to read. So I'm going to put a star by this one and write read. Because not all of them are just going to be, boom, we just blindly multiply. Okay, an umbrella company can make 75 umbrellas a day. Complete the chart and determine how many umbrellas they can make in 2 weeks. Okay, so here's what just happened. They're asking us to do 2 things. Fill in this chart, but then keep going and write 14, because that is how many days are in 2 weeks. So here we go. We got 75 times 2, that's 150. And then 75 times 4 is 300. Again, you have some options here. You can either just do 75 times 4, or you could say, listen, this is going to double, right? Now this next one doesn't double, sort of. It is going to add another 150. So, I mean, I know that it's 450, but it doesn't double from here to here. I guess instead of writing that it doubles, I should say we are adding 150, adding 150. And if you're like, why adding 150? Because this is going up by 2. That is going up by 2. That is going up by 2. So over here I get 600. And if you're like, oh, okay, so then this is just going to be 750? No, because notice that 14 breaks our pattern here, right? It goes from 2, 4, 6, 8. The next number, if you were counting, would not be 14, it would be 10. So if you want to, you can go and do that little math on the side. 10 would give you 750. 12 will give you 900. 14 then would give you 1,050. 1050 right there. So that is us talking about proportions versus not proportional or non-proportional. Let me know what questions you got. See ya.